Alright, let's pick up with the last two pages, numbers 8 through 11. There is some tricky stuff in this last part, so you want to pay attention here. I did go over most of these in class today, so hopefully there won't be too much of an issue, but let's go ahead and go through them. Alright, number 8. You first want to set up a scale. So I'm going to make each one worth a quarter. You can make them worth whatever you want, but I'm going to make each section or each block worth a quarter. There's 1, there's 2. Okay? So I start at 0, 0. I end at 1, 1. So that's my first segment. I start at 1, 1 and end at 1, 0.5. I start at 1, 0.5 and I end at 2, 0.5. And I start at 2, 0.5 and end at 2, 0. Okay? So this is my curve right here. Now there's a couple of different ways that you can look at these. Okay? The first is that you can kind of look at what each of these little blocks would be worth. Okay? So each of these little blocks is a quarter, quarter times a quarter. And a quarter times a quarter is a 16th. So each block in my model is worth a 16th. Okay? So I should have 16 blocks here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then 1, 2, 3, 4 halves makes 2 wholes, so there's my 16 blocks. Okay? Now you could also calculate the area of each section. It's up to you, however you want to do it. Now, as far as finding the probabilities, remember this is your x-axis. Okay? Or you can actually write it uppercase X. Okay, this is your x-axis. So these are where your probabilities are. Okay? So what's your probability that x is greater than 1.5? So I'm going to switch colors here. 1.5 is right here. So what is my probability that it's greater? Well, if you notice, the area that is formed is a square. My square is 1/2 times 1/2. So I can do 1/2 times 1/2 and I get 0.25. Okay? I could also count 1, 2, 3, 4 sixteenths, because each one's a 16th, so 1 16th, 2 16th, 3 16ths, 4 16ths, which is, again, a quarter. So there's a couple of different ways that you can do this. Alright? Now, the next question asks x is greater than or equal to 0.5. Does it really matter that it's equal to? No, because in a continuous random variable, if it's equal to, your probability is always 0. Okay? So they'll ask when 0. Let's go back to letter C, though. Alright, so I'm looking for all of this area that is greater than 1/2. So that includes the area that I just found in the previous problem. Okay, now, again, you can do this one of two ways. You can count how many blocks you have shaded, and again, that's in the green this time, or you can take the complement of what is not shaded. Okay? What's not shaded is 2 of the blocks. 2 holes. So I have a half here and a half here and a hole here. So 2 16ths are not shaded. So how many are shaded? Well, that should mean that 1 minus 2 16ths is 14 16ths or 7/8. Okay? So one way or another, you can count those, or you can break this into actual areas. So you have a rectangle here you could calculate the area of, and a triangle here you can calculate the area of. Whatever way you want to do it, this is really just geometry. Okay? So it's really just calculating areas and breaking up with scales and stuff like that. Okay? Alright, number 9. Alright, number 9, this is where you have to know all of those rules that were on the first page of your review sheet. Okay? So this one, the difference of y and x for the mean and standard deviation. For mean, you should know that the mean of y minus x is equal to the mean of y minus the mean of x. So you literally just take their means. The first mean of y is 2.001. The mean of x is 2. You subtract those, you get 0.001. Standard deviation. Remember the standard deviation of x, or excuse me, it's y minus x, the standard deviation of y minus x, you can't use standard deviation. You have to use the square root of the variance of x of y minus x. Keep doing that. Okay? So we're going to first calculate the variance. So you want to take the square root of, how do you calculate the variance? You basically take the variance of y and add, remember, the subtraction is actually add, the variance of x. Okay, that's one of your rules on the front of your sheet. If you don't understand that, go back to the rules on the front of your sheet and look at that rule. Okay, so now I'm going to take my standard deviations that is given, and I'm going to make them into variances by squaring them. Okay, so my standard deviation of y is 0.001 squared, plus my standard deviation of x is 0.002 squared, and when I put all that in my calculator, I will get that my standard deviation of y minus x is equal to 0.00, let's see, is equal to 0.0022. Yeah. Okay. Alright, now, next question. This one isn't that bad. Okay, I have this z here, which I want to find the mean of z, which is x plus y divided by 2. And I want to find the standard deviation. Let's focus on the mean first. Mean's pretty easy. Mean, you just take the mean of x plus the mean of y, and I divide by 2. That's it. Okay, so that one's not that hard. So 2 plus 2.001 divided by 2 gives me 2.0005. Alright. Standard deviation is a little bit more tricky. Okay? Because first you have to find the variance. So remember, standard deviation of x plus y divided by 2. Alright? You first have to find the variance. So I'm actually going to be taking the square root of the variance of x plus y divided by 2. Well, how do I find the variance? Let's focus on that first. Let's focus on finding the variance of x plus y over 2. Alright? Now, rewriting this, I'm taking the variance of x plus y and half of that. Well, how can I rewrite half? If I don't want to write divided by 2, is dividing by 2 the same as multiplying by 1/2? Of course it is. Okay? So I'm actually taking half of x plus y. Well, that is the same as the variance of half x plus half y. Okay, now going back to that rule that we talked about on the very first page of this packet. Okay, all the way back here. Oops. Okay, so remember, the a value doesn't matter. Whatever you're multiplying by, you're actually going to end up squaring and multiplying by the variance. So whatever that coefficient is, you square and multiply by the variance. Okay, so let's go back to our problem. Okay, I'm going to take the x, I'm going to take that coefficient of x, and I'm going to square it. And then I'm going to multiply by the variance of x. Well, the variance of x is the standard deviation squared. So I take 0.002 and square it. Okay? And then I'm going to add to that, same thing, 1/2 squared for y, and then take the standard deviation of y and square it. Then finally, once I get that answer, which is about 1.25 times 10 to the negative 6th, I'm going to take the square root of that and wind up with 0.001. Okay? So just be careful when you're working with those rules of standard deviations and variance. Number 10, at first glance, you have 4 choices that cannot be a binomial model then. However, look at the first question. If you guess, what is your probability you guess correct? So the probability you guess correct is one of the cards is correct out of 4. So what's your probability of incorrect guess? 3 out of 4. So you do have a binomial model in your hands. Okay? So correct, incorrect are your 2 categories. Each guess is independent of the next. You have 20 cards you're taking. Same probability of 1/4 for each card that you graphed correctly. Okay? So this is a binomial model. Again, don't forget to write your probability statement. So what is the probability that you guess at least, which is that many or more, at least 10. So you're going to do binom. Hold on for a second. Let me go back. Since this is a greater than, you always have to take the complement of. So 1 minus binom, I want to use CDF because, again, inequality. Okay? And now the question is, what do I put in here? Well, I'm going to put my 20 cards that I have. That's constant. Okay? My probability of 0.25 or 1/4. And now, I want to include this 10 in my solution set, in my probability answer. Okay? Now, if I put a 10 here, that complement is going to undo the fact that I'm including the 10. Because complement is opposite. So if I include 10, the opposite of including 10 is not including 10. But that's not what I want to do. I want to include it. So I'm actually going to do 1 less. So I'm going to put a 9 there. So now I am going to put that in my calculator, 1 minus binom CDF, and I get 0.014. Okay? In many repetitions, the subject guessing, how will the subject guess correctly on average? Average is mu. And for a binomial model, you just take n and you multiply by p. So therefore, you get 5 cards. 5 cards. Okay, standard deviation is the square root of 20 times 1/4, and we already found the complement, which is 3/4. Multiply, take the square root, you get 1.936. Okay. Last question, number 11. Suppose probability of being a brunette is 0.68. Suppose that 200 students are selected at random. And again, same probability for everything, same number of students. You got a binomial model. Okay, of course you have the independence, so one person being a brunette has no impact on the next person being a brunette, so therefore they're independent, and so you're good to go. So what is the probability that between 100 and 120 and 130 inclusive? So the probability of between 120 and 130. Okay? So what I'm going to do is I'm going to take my binom CDF all the way up to 130, the top of my probability. Okay, so 200, 0.68, 130. Now, I need to subtract out some things. I don't want anything up to 119. So then I need to subtract out everything up to 119. So 200, 0.68, 119. Okay, and when you do that, you can put all that in your calculator and you get 0.195. What is the expected? Expected, you should know mu is just n times p, so 200 times 0.68. And 200 times 0.68 is 136. And finally, what is the standard deviation for the expected number of students that are brunette? Standard deviation is equal to the square root of 200 times the probability times the complement. Put that in your calculator and you get 6.597. Alright, so chapter again 16 and 17 with the exception of geometric from 17. No geo. Okay, good luck studying. If you have any questions, let me know.